All right. That was very, very useful.
Hi, everybody. Thank you for joining the session. I'm Giora. Let me see if I can have access to the deck. If I'm showing the deck here, great, perfect. So a little bit about myself. I'm the co-founder and CEO at Neosec. We're an API security company. Previously, I was founder of a company called LightCyber that started the concept of XDR, what's known today as XDR, and then was part of Palo Alto Networks as part of our journey back then. And today I'm going to speak about API discovery and why it's the first thing that we start with, but why it's definitely not the last thing. I'll share some common experience that we get from customers going through challenges of doing discovery, and then the next step that they take after that. So again, hope to keep it interactive with some questions in the end, and let's start. So why discovery? Why do people start from discovery? Why is it so important? So discovery is really the very first basic problem that we have. It's really understanding what we have, and once we know what we have, we can think about what is wrong, what is vulnerable, what can we do about it. But API discovery became a big problem recently because there are so many new APIs that get developed. Originally, when we looked at original web applications and the kind of the legacy stuff, we used to have mostly web applications, mobile applications, these big monolithic applications that we expose to the outside and that are part of our typically WAF implementation and so on. But today there's so many more APIs that we expose both internally in an east-west manner between microservices, as well as externally to support different types of applications, not only the the monolithic applications, but also different types of services, from authentication and data access and money movement and a lot of different things. So there are a lot of different new APIs, and I think the number of API services that people see today is maybe 10 times or more than what they ever had before. So definitely, discovery is one of the first steps that you need to take in order to find all these APIs. Now, just to mention that concept of the fact that APIs can be either externally facing, like the north-south APIs, as well as east-west, that is more internally facing between different applications. So if we think about the legacy applications, the web and mobile applications, we still see them as externally facing applications, but typically those monolithic applications use a small amount of APIs. They're very focused on rendering some user experience, and in the meantime, the new types of web applications that we see leverage many more APIs. So for the same use cases, if you think about APIs today, there are many APIs in every web application. Not to mention these APIs that are partner facing and are not even meant to be used for a web application. They're actually a machine-to-machine interface that is implemented between a company and partners or suppliers or even customers that leverage these APIs. So there are a lot of different applications, a lot of different use cases, and this is why there's API sprawl. And the first step is really doing discovery. Now, I wanted to share research done by EMA, the analyst group EMA that we just recently the research was just recently released. If we look at that research study, it looks like most of the people think that their APIs can be discovered by their WAP, by their API gateway. So this is really a misconception and confusion that a lot of security teams have. And it's not that it's not true. Some of the APIs can be discovered by your WAP, for example, if you have one of the WAPs that does that. But a lot of the APIs that you're building today are actually not exposed through the WAP, and in that case, the WAP cannot see it. Right. So, for example, if you're writing your new services in AWS and you have different types of environments. Some may go through a WAP. Some are actually go directly through AWS. Some go through an API gateway. So in order to discover APIs, you really need to be thorough. You need to go in different environments and do it thoroughly, because really what we see out there is that most of the new APIs are actually not gated through a legacy WAP from that perspective. So that actually shows, some of the misconception that exists out there. On the other hand, most people know that the level of discovery that they have is not sufficient. So again, just to illustrate it again, APIs really need to be discovered everywhere, not just in your WAF environment or WAP, not just in your gateway, but also everywhere else. And what we're seeing is that most of the new APIs and applications that get developed these days are actually not in the not necessarily in one environment. They typically get developed in new environments and so on. So it's really important to go beyond the well-known environment if you actually want to be able to discover your APIs. So I think now it's actually a good timing to describe a little bit what's the difference, or where do you use the WAP or web application firewall, and when do you use the gateway versus where do you use API security? Because these three product categories are actually complementary. They're not instead of one another. So you use the WAP, use the web application firewall mostly for web traffic. For cases where you have a lot of unauthenticated traffic, and you need to make sure that only good traffic gets through. In cases where you have some common attacks, where you want to use signatures and so on, this is where the WAP shines. It can really protect your environment. But there are a lot of problems that the WAP doesn't solve. For example, visibility into B2B APIs or east-west. Discovery of APIs outside of that particular WAP platform is not included. API abuse, different aspects of visibility into the API behavior itself, understanding what is going on, and so on and so forth. So when you want to go beyond, just the pipes and getting your application, and you want to make sure that you're covering all the different environments, you have to go beyond the WAP for API security. API gateways are actually a different component, and they're used in many stacks. Typically, from my experience, every time that we see an API gateway, it's a place where API security is really a must, because the gateway itself only exposes some basic functionality, and actually that functionality is not a security functionality. The gateway itself is actually part of the I would call it the deployment of the application. So it provides, for example, authentication authorization services. So your APIs won't be able to you won't be able to access your APIs unless you get authenticated and authorized. Gateways also implement rate limiting and other policies. But what they don't do, they don't really discover your APIs. They don't understand the posture of your APIs. They don't really know the specific APIs. They really know about the domains and the policies, but they don't really understand the specifics and the nuances of the APIs. And of course, when it comes to detection and response, it's beyond the scope of these products. So maybe just bottom line, you need to have both capabilities. If you have a WAP or if you have an API gateway, you still need API security. So I got a question from the audience. I see. I see that some people have trouble seeing the screen. We can share the deck afterwards. Okay. Okay. So maybe continuing to the next slide. Now, if you ask people, and this is just recent, that research was just completed a week ago. So what do you perceive to be the most important capability of an API security solution? So here, of course, Discovery is one of them. Discover APIs. It's still small, so I'll read it for you. Discover APIs for both documented and undocumented APIs. But when people are asked about API security, when they implement API security, they say that they actually need. I mean, the highest ranked answer is actually tools for proactive investigation and threat hunting, integration with other tools, and provide end-to-end visibility of breach attempts, runtime protection for APIs, API-specific security testing. So there are actually quite a few other things that you need to do when you go with an API security solution, and that I think is a very I think insightful piece of information, because while discovery is typically the first thing that we do with an API security solution, the discovery is only the first step. It is never meant to be the last step. It's never meant to be the ultimate goal. It's just the first step. You have to discover it to govern it. So you really have to do discovery first, but then you actually implement API security in order to actually protect your runtime of the APIs and prevent abuse and so on and so forth. I'll share a link to that report in the end where you can get more information. It's actually pretty insightful. So now let's go back a bit and speak about the different areas of API security. And the first area is shadow APIs, and here discovery is really the solution, or this is where discovery fits. So the shadow API section is really all about understanding what you have, getting the asset inventory, and so on. But the asset inventory by itself is, of course, not enough. This is typically, I mean, it's marked here as today's focus because most people don't know where to start. They need to start from getting a good inventory. That's pretty clear. But once you have an inventory, the next step that you're going to ask yourself is: are these APIs vulnerable? Are they carrying sensitive data? Where do I need to look at in order to solve that, and so on? So then comes the second component of finding vulnerable APIs. That's a pretty big space where you want to focus on finding these vulnerabilities, misconfigurations, and bad practices before they actually hit production, or early as they hit production, so that they won't be abused and used against you. Most of these vulnerabilities can be categorized as OWASP top 10. And of course, OWASP top 10 is just the categories. There are a lot of the nuances and different types within. But then, let's say everything is vulnerable. What then? And so we see that even if all of your APIs are really great, everything is well designed, you still are exposed to API abuse, because your APIs are out there. They need to serve the broader set of customers or partners. You typically have different ways of onboarding new users to your system. I mean, a lot of platforms enable many types of onboarding that enable anybody to open a new account and start transacting and so on. Let's say if you're a bank, you have a lot of different users and onboard new users every day. So how do you make sure that the authenticated traffic, the users that seem to be good users, are actually not abusing your platform and not leveraging some business logic abuse? So this is the third category. So again, starting from the beginning, first you discover your assets, then you find vulnerabilities to reduce the attack surface. And lastly, you need to continuously monitor that behavior and find different types of abuse. So through the presentation, I'm actually going to share more information about each one of these categories with some data from that survey, from that research. So let's speak about vulnerable APIs. So again, taking some information from that research study, it looks like over 40% have only less than half of their APIs documented. That means that the rest of the rest of the APIs are not documented. And actually, I would say, based on my experience, that it's an understatement. I think in most environments that we see, people have many more APIs that are not documented. It's just that if you ask them without without the actual discovery, they assume that they have more documentation than they do actually have, because some of their documentation is not complete, doesn't cover all the services. Some of it is actually old and not up to date. So all in all, you typically get much less than half of your APIs documented. And then from our risk perspective, again, the research shows that about a quarter of organizations have no visibility into which applications are processing sensitive data. That is really part of discovery. If you discover all the APIs, it's not only that you know about the APIs, you know about the services and applications that they're part of. And good discovery should also show you, what type of data goes through the APIs. Is it PII? Is it some kind of financial data, and so on and so forth? That's really part of the discovery to solve that. Now let's speak about real-world API security problems. So one of the posture alerts that can fire is a case of Ebola, and in which in this particular case, I'm sharing a specific customer case here. So in this particular case, an unauthenticated user scraped customer data of a loyalty program. In that particular case, there are many different types of broken authorization. But in that particular case, it was an unauthenticated user that could access another user context that was authenticated. There are a lot of nuances there. Now, in order to know what actually happened and take the next step, you need to investigate. Typically, you need to see, what happened, what was the source of the problem, and it turned out that the API endpoint could be exploited to get the full PII in cases where it shouldn't actually give you the full PII. And again, in that case, the endpoint was meant to be internal, but was actually accessible from the internet. So again, there are a few things to unpack here, but but this is a classical posture issue where an API is exposed while it's not supposed to be exposed, and it causes other types of attacks because of that. Let's take another more common or very common posture issue. This one is from the insurance industry. In that particular application, the customer found that they have sensitive data going in their URL. So this is really a bad configuration. It's not a good practice to send sensitive data in the URL itself, because the URL can be cached in different places, and it can be visible to in places where you don't want it to be visible. So for that reason, the remediating this problem is relatively easy. You go back to the developers, you show them with the evidence, and then they can change the implementation so that the sensitive data doesn't go through the URL, but instead goes through the payload. It's a very common one. Okay, so now let's speak about abuse. And when we speak about abuse, we speak about perfectly written APIs that are by themselves not vulnerable, but still, they can be abused by an attacker. because the attacker can masquerade as the real user, for example, through account takeover, or the attacker can actually open new users by themselves and create new user contexts and abuse the platform. So let's first look at some real-world security problems, again, from that we saw in different customer environments. So this one is from a restaurant management company. And so you can imagine some kind of a digital platform, and we see some kind of behavioral abuse, which we call impossible time travel. We see some cases where interleaving logins from the same user come from different locations. So that case shows us that there is some set of credentials that is actually shared or stolen, beyond the original user that should have the credentials. In that particular case, after some investigation, it's there were some passwords that were easy to guess, and one of the resellers shared their credentials, with prospects and customers, and that got propagated from there. So again, I mean, this is a case where you can find in runtime that the same credentials are used from two different locations. So that's what we call impossible time travel. This is another interesting one from the gaming industry. This is actually really, really interesting. So in that particular case, we've seen an abuse case where there were some sessions that were abnormally long. So typically people go and play, let's say, play a certain online game, and then when they're done, they disconnect, right? I mean, there's a limited limited amount of time where you can sit in front of a game. But when we saw these abnormally long sessions, it looked like people were there for 24 hours or something like that. That didn't make sense. I mean, a human cannot be in a game for so long. So what ended up, the case ended up being that there was some automation that was leveraged by some attackers that would create these fake users and compete against real people. But naturally, when they gang up on these people, they can actually, they have more information, so they can win these games. So they made some changes to their platform after they saw that type of abuse. So that's a real life example from the gaming industry. And another one that is also related to gaming, but in this case, it was a former support employee that was using their credentials, and again, I mean, using these credentials in a way that was abnormal, but also beyond the time frame that it made sense. So when we saw that abnormal behavior, they discovered that it was actually a former employee that and these credentials should actually not exist anymore. Another example, again from gaming, is abnormal geolocation. So this is where, and that can actually happen in a lot of different cases, where a client connects from a completely different place, where they typically always connect from the same place. I think it becomes even stronger for B2B APIs. We've seen that for B2B applications, when the client is actually a permanent implementation rather than a specific user-based implementation, like a specific it's not a web or mobile device. It's actually a B2B implementation where it's a machine-to-machine code that's running. Abnormal geolocation is very rare, and it only happens when the credentials are stolen. In that particular case, in the gaming industry, the player spoofed the geolocation coordinates, and in order to avoid some restrictions. So this is again an abnormal behavior that was trying to overcome some of the application's restrictions. So now, after showing all these specific cases, I wanted to speak a little bit about the concept of abuse case analysis. That's a super important concept. In the end of the day, when you implement API security, you implement it in order to avoid these abuse cases. And that actually becomes specific for the business. So let's speak a little bit about how to come up with these lists of abuse cases, and how to find for your business, for your company, which abuse cases matter. So typically we always start with identifying what you expose. So again, here there are some examples: new account creation, paying invoices, authentication, reservation systems, paying transactions, doing some money movement operations, gift cards, and so on. Everything that you can think about, right? So that would be really your core applications of different kinds, but you can divide it into different different types of apps or different types of services from that perspective. Okay, so so now once you know which services you expose, and by the way, this is a completely logical list. I mean, it doesn't have to be the list of all the APIs. It's very, very high level, and that's what makes it robust and useful. Then your next question that you need to ask is, who's using these APIs? Are these end customers? Are these B2B partners? Are these support users? And so on and so forth, right? So that gives you a hint on what can go wrong. So for each one of these services, you need to write down. I mean, is it externally facing? Who is the user? Is it a person? Is it a machine? And so on. Now, the third step is to speak about the security risk. And security risk is starts with first identifying what could go wrong. So here in the security risk, first you ask yourself, what happens if the client gets compromised? What happens if the client is misimplemented or making a mistake? So all these questions come here, and then that leads to the potential loss, because when the user is compromised and somebody else has access to the user's data, depending on the application, that can cause some monetary loss, right? It can cause some money to move out of the account, or it can be a PII loss where information is lost or shared, and so on and so forth. So what I shared here, is a good framework for identifying the different abuse cases that matter to your company, and that is typically these use cases that matter to your company are the reasons why you need to invest more in API security, both technology and processes. Now, the last problem that we see is, after you talk about these abuse cases, you immediately think about, what are the next steps that I need to take? How do I investigate? How do I respond? And that seems to also be a problem. It turns out, based on the research, it turns out that the ability to perform threat hunting and investigation is really, really high. So it's very important for an API security platform to enable that, because naturally, if you found an attack, and you believe that there is a good detection, the next thing that you'll do is to find out more context. What did the user do before? What did the user do after? What exact records were accessed? Is that data compromised? Do I need to notify people, and so on? So you need all that context, and this is why investigation and threat hunting really matters, for API security. The one thing that I wanted to share about investigation is that it's actually not very common to have these capabilities. A lot of people think that they have their logs, and I'll explain in a second. They typically don't have enough information to actually understand what happened. So this is definitely an area that can use some improvement. So just to mention all the information that you saw here on the on the security research report, you can actually access it on our website. You can go to neosec.com and find that EMA research report there. It was conducted by EMA, which is an analyst group, and they surveyed about 1,000 different companies. So that's all available there. So please, go ahead and find that information. There is much more information there. I just used a few anecdotes. And now I actually wanted to spend a little bit more time on unpacking what we spoke about, creating some kind of a maturity model or a step-by-step process where we can take our organization from where it is today to the full maturity. And I'll leave some time for questions in the end. Here, I mean, we started with the three main blocks of detection of API discovery, then posture analysis, then abuse detection. So this diagram here, this model here is a little bit more nuanced. It shows a few more steps in between, and I think it's useful to see it in the context of after we spoke about the big steps of discovery, posture, and detection. We can actually go a little bit deeper. So most organizations have the basic controls today when it comes to their APIs. Most organizations are in step 0. Step 0 or step 1, depending on the case. And let's say you implemented your APIs correctly. You have some services that are even already in the air. And of course, these services are critical to your business. Now, the question is, first of all, do you have visibility to your API activity? Most people would answer yes first, but if they think about it, the level of data that they have is very limited. They only have visibility to some logged data, which is very high-level logging. They don't really know the user context. They don't know the internals of the API context. So the visibility is somewhat impaired, with what you have today. So really, the first step in the API security space is to have the right visibility, to have visibility to the whole traffic, and to know exactly what happened in these API calls. Now, the next step is discovery. We spoke about it pretty thoroughly. Again, you need to discover it to govern it. It's discovery is kind of the basis. Without the inventory of the APIs, it's really hard to take the next steps and talk about risks and vulnerabilities and even abuse. So discovery is definitely a foundational element. Then once you have a good inventory, you ask yourself about the risk audit. Which APIs are risky? Which APIs are misconfigured? Which are not documented properly? Which have sensitive data and so on? So these doing the risk audit is really for discovering these posture alerts that enable you to improve your APIs. Because if you have better posture, you're less likely to be attacked. So you're reducing your attack surface. It's important to mention that in the risk audit and in general in API posture, there's a difference between different environments. So if you look at the let's say testing or dev environment or even your staging environment, you may miss some real risks and posture issues that only exist in the production environment. So when we do posture, it's really important not to do it only on the lower environments, but also implement it in production. It's super important. Then let's move to the next steps 4 to 6. So again, once you're comfortable with your posture in general, you have more time or you have the right tools to focus on behavioral detection. Behavioral detection is really what's I think what in the end of the day we're here for, right? I mean, in the end of the day, it's not just about discovering API. It's not about just finding the risks. We want to make sure that nobody's abusing our application platform. That nobody's stealing data. Nobody's is abusing it in all sorts of different ways. So detection capabilities are typically the next step. And the question here: can you detect misuse or business abuse beyond just the common WAF signatures, right? Because the common things are typically already filtered out by your WAF platform, but here you need to be able to discover that normal traffic, that authenticated traffic that looks normal, but it's actually potentially abusing your platform. So some portion of it might be bad traffic. So detection is definitely the holy grail. Once you detect, you need to be able to take the next steps. So detection leads to response. Response enables us to take an actual remediative step. Like, for example, we can block traffic once we detect something. We can revoke credentials. We can start some kind of SOAR playbook and so on. So response functions are could be a lot of different functions. I would say that even for risk audit posture APIs, posture API alerts, responses are also relevant to notify the rest of the team, to send a Giora ticket to the developer, and so on. But then after response, or sometimes even before response, you want to be able to do some investigation and threat hunting. So it's not that you're expected to sit in front of the screen the whole day and look for threats, but in order to actually take the next step, do some remediation, or decide what to do with that user, you actually need to be able to investigate what happened. You need to be able to threat hunt, see if it happened in other places, and so on. So again, this is the last level of the maturity model. If you can do all of that, you're pretty mature from an API security perspective. Most companies are really starting from step 0, and but I think with the right technology, with the right process, they can go through all these different maturity levels. And of course, even once you get to detection and response, you still need to be doing discovery continuously. You still need to be doing the risk audit continuously, because these APIs change all the time. But when you have the basis, you can have some effective detection and response processes that can actually take action and prevent some abuse from happening. So maybe just saying a few words on the Neosec platform. So naturally, we cover all these steps 1 to 6, or in this notation, these 3 main pillars. We do it by continuously discovering our APIs, the APIs, and showing any new API, especially if it's not documented, but in any case, regardless of documentation. And then we can detect all the vulnerabilities. These vulnerabilities are detected continuously because there are always changes in the APIs and so on. And we can also cover behavioral analytics by learning the normal behavior of each and every user or client in your APIs, and finding what's abnormal, what seems like abuse, and then we can respond to that automatically. We do all of that with on top of our visibility platform. Our first foundational element is being able to see everything, see all that traffic, all the API calls, and be able to make that investigation of what happened, when, and how, and all the analytics and of course investigation capabilities leverage that data set. Again, if you want to learn more, go to our website. You can find the research report. You can find other important documents. I think the critical capabilities one is pretty useful. It speaks about what are the critical things that you need to look for when you look for API security, and explains why these different capabilities are important and how it relates to your business. So I think with that, I'll open it to questions. Okay, so I see some questions here. Just for learning more about the topic. Naturally, there are a lot of resources on our website. A lot of resources that also explain what APIs are, what different types of APIs, how different APIs can be leveraged for attackers and so on. So there are a lot of information out there that you can use that is not related to our product, and also of course information about our product that you can access there. I'm looking if there are more questions. I know that there was some kind of trouble, with the Q&A. So I think I'll end it here. Thank you very, very much for attending the session. I'm happy to to answer any questions offline. You can always send us an email or contact us through the website. I'm happy to answer questions regardless of our product. And thank you very, very much. And also I was told here to tell you to come back at 1:15 Eastern after the break.